Hello everybody, Adam Lusek here, and today we're going to be talking about the Model Context Protocol, or MCP. The Model Context Protocol is an open source standard for connecting language models to different data sources, introduced by Anthropic in November of 2024. The reason that Anthropic created the MCP is mostly because they identified that when you're building language model-based applications, pretty much every new data source integration requires some custom implementation. So this aims to really standardize the way that language models at runtime interact with different data sources, tools, and systems by providing this universal open standard to connect everything together. So the expectation is really, if you're creating some sort of AI-based application or language model-based application, rather than creating all of these custom integrations over and over every time, we can standardize this by creating an MCP server to expose that data and then build a AI application or MCP client that is able to talk to and connect to those servers. For a quick example before we go into the details, we can use an MCP compatible client such as the Claude desktop app, as well as an MCP server that has different web surfing capabilities, and then give Claude the ability to actually search the web. So it's able to now understand that it has all of these tools available and actually also use them, which, as anyone who's used Claude before knows, could not historically actually search the web or load different web content. So to break it down a little bit further, I have this quick diagram that I put together showing the host or language model application, the different clients and the various MCP servers all working together and exposed via a front end. Given our example of the Claude desktop app, that would be our application and front end, with the client actually connecting to the web surfing MCP server in the back. These three components can be broken down as such. The MCP servers handle more the tool availability, exposing what kind of functions are available to a language model, the tool execution, so running those functions and then returning back the results, and then also static content as resources, which can be provided data that can be inserted into the context of a language model, as well as preset prompts or standardized templates for different common tasks that are set up by whoever created the server. Clients then manage the connection to the MCP servers, the different language model integrations, and then also passing the messages back and forth between all of these components, which is all surfaced by the host, which is of course the front-end interface, which surfaces the MCP client functionality to the user, as well as your general AI or language model-based applications, various components. If you're familiar with different client-server architectures, this is probably no foreign concept to you. However, if you're just getting started with this stuff, or you mostly focus on just language model-based applications and haven't gotten into something like this, it can be a little bit confusing. So I'll break it down in each of the most important parts. Do know, however, that the Model Context Protocol has wonderful documentation here, which I'll link below, that goes into the nitty-gritty details and schemas for those who are interested. But as we touched on a little bit before, what this architecture then allows you to do is create this modular system where all of these different components can be developed independently while maintaining interoperability. In the end, what this allows is for developers to make these MCP servers that very strictly govern how the different interactions between a language model and an expected data source actually work, and then be able to plug them into any sort of MCP supported application. A lot of the common use cases that I've seen are things like integrating different services or APIs and tools together, or connecting local data sources on your machines to LLM applications like Cursor or Claude. While this definition is a little bit open-ended and abstract, you can see from this list of kind of official and community model context protocol servers what some people are starting to think of when integrating these. There's all sorts of stuff like file access and search capabilities for Google Drive, Postgres compatibility, different memory implementations, and all sorts of different official integrations into different companies' APIs. We'll be going over how I set up my own custom little MCP server and client as an example here in a second, but to further understand that, let's talk about different MCP server components now. The MCP servers can be summed up as the foundation of the protocol that expose and standardize different capabilities through all of its interfaces. So hosts and clients can then connect to all of these servers using this protocol standard, but how these capabilities are presented and actually used to the users remains pretty flexible and open to the developers. That means really that the end application, whether you're using something like Claude or something like Cursor, is up to, whoever the developer is, but the actual connection is going to be standardized, allowing for this easier development and also strict control over the interactions and data being surfaced to the application. And so with that, MCP servers have three main components that I see used a lot. That is tools, resources, and prompts. Tools are going to be the traditional tools that language models tend to use, functions that an LLM can invoke to perform actions or retrieve information. Resources are going to be more data sources that can be accessed by the client application or provided as context back to the language model. And then prompts are going to be reusable templates that define specific interaction patterns. None of these are really anything new if you've been working with or developing with language models, and it's likely that if you're, watching a video on MCP servers, you probably already know a little bit about how tool and function calling works and, how to pass maybe a PDF to a language model. But the way that this is all handled in the client-server interaction and how it's standardized and connects is what makes the MCP server so powerful. I have a little bit of the specific schema that the tools, resources, and prompts are actually passed back and forth with from the client to the server, but the easiest way to actually start to understand this stuff is to get into a literal example. So I'll point out a few more of the specifics along the way, but let's actually get our example outlined. So to highlight tools, resources, and prompts and how MCP servers and clients actually handle these, I'll be creating an MCP server and then a very simple example command line based chatbot that is going to act as our client. One of the more popular examples that I've seen are setting up different MCP servers to be able to query and parse and understand different knowledge bases. So I'm going to introduce some RAG functionality as well as some static documents into a full flow and experience with these three different components. So in the back, I'll of course have a vector database set up, and then along with that, I'll have two tools that are handled by the MCP server. That's going to be a query document tool to search the vector database, and then also a get collection info tool to grab different details and metadata about the database itself. Outside of the vector database, I'll also have a couple PDF documents, and those are going to be exposed as resources in our MCP server, and it'll handle both letting the client know that these are available, as well as passing it over to the user in our client. We'll also have two prompt examples. One is going to be a deep analysis prompt that is going to look closer at specific document details, and then the second is going to be an extract key information prompt that will extract specific content from documents given some sort of query. So with that, the only other setup that I have is just setting up a simple ChromaDB vector database. I'm going to be using one of my favorite examples, the Ultimate Guide to Fine-Tuning LLMs, mostly because it is a 115-page, super dense, worded document that is great for embedding and doing retrieval on as my candidate document. The rest of this very simply makes a Chroma client and then uses some of LangChain's built-in text splitters and PDF loaders to load the PDF, split it, and then insert it all into our database, which ends up getting about 555 individual chunks. So hopping over to our IDE, we can start going through the different components of how these servers actually set up. I'm going to gloss over a little bit of the specific details of how each individual function actually works to mostly hit on everything that you kind of need to know at a baseline. So if you are interested in how any of these kind of things operate or the code behind them, do please check out the documentation that I referred to earlier. But for this specific knowledge base server, I have all of my dependencies here imported, as well as set up some logging and loading all of my environment variables. Most importantly, my OpenAI API key. I'll then create my main server class by using the server function here, passing in a simple name of just document search. This is of course imported from the MCP package. All of this following code is then just used to initialize our ChromaDB client. So it will try to connect to the client, which we have as ChromaDB, which we set up in our notebook a little earlier. This all just connects to that, uses a custom embedding function that's just going to use OpenAI's embeddings because that's the same one that I use to embed our documents, and then also get the collection. This will be useful later on as we define our functions to actually do the querying of this. And so you can already see how we're starting to set up the ability for our client, which is going to be our language model chatbot, to be able to actually interact with different data sources that are locally stored on our computer. Of course, if this server was something that was hosted, this could also talk to maybe another hosted vector database and be able to do that interaction that way. But with our server initialized and our connection to the ChromaDB client here, what we can do is actually start to get into more of the specific MCP server functions. As this protocol is meant to be a standard, they have their own typing for things like resources, tools, content, image content, and all sorts of these things, which we'll be using along with some decorators. The first of which is going to be the list tools decorator. We're going to put this on top of a function that actually handles listing out the tools. And what this will allow us to do is that for a client that's connected to the MCP server, it can call the list tools function to be able to get a list of all of the available language model compatible tools on the server. So as we went over in our planning, this will return back two tool objects. The first of which being the query document tool, and the second of which being the get collection info tool. This also has, of course, all of the different properties with the descriptions of what it does, as well as the required arguments for the tool. Jumping forward a little bit to our client code here, what having all of the tools in the server with this decorator allows us to do is call the list tool method and ping the server from our client to be able to get the information of all available tools. We can then handle that client side for actually formatting these into functions available for our language model. So with just something like this, that's a standard way of taking the MCP objects and converting them into the OpenAI API spec. We don't have to actually write out all of the tools for our integration. We just need a connection to the MCP server and a way to actually ping it to see the available tools. And if you're starting to catch on a little bit, not only are we listing the tools, we're also going to handle actually calling the tools server side. So once again, back over in our client, rather than handling all of the different tools client side, what we can do is just pass in the tools names and the tools arguments from the language model's output and call it on the server, which we then will handle the execution of on the server with the call tool functionality here and our handle call tool function, and then pass that context back to our client. So in my specific scenario, when we get a ping to call the tool, if the name of that tool is the query document tool, we're going to verify that we're connected to ChromaDB, run through a quick similarity search, and then process all of those results. This is returned back to the client as a text content object, letting it know that it is text along with the actual string here. And similarly for our second tool, get collection info, when that is called, we'll make sure that the collection is actually initialized, grab the count of the collection, and return all of that information back in a text content object again. Hopping over to the client then, we can see this all come together by seeing that all we need to do is actually call the tool for the server, get the content back, and as long as we're able to process in a format of this text content object, we can do anything we'd like, which in this case is just appending the tool results to the conversation and then running that all back through to get the final response from the language model. So to sum it up for tools, handling actually what tools are available and then the execution of those tools are all going to be on the MCP server. And then a compatible client will be able to talk to the server, see what tools it has available, and then also call those tools and get the responses back from the server itself. Super useful for if you just want to create some sort of integration or function call and be able to plug it into a client that actually has the compatibility with this stuff, as I showed with my example of something like the Claude desktop app. So with a little bit of how tools are used, let's talk about resources. And I want to hop back to my notebook here to discuss a little bit of a note that I have. And that is that while tools, which we just went over, are designed specifically for language model interactions, which is essentially function calling, prompts and resources, which we're about to go into, serve a little bit of a different purpose in the overall model context protocol ecosystem. Prompts are typically going to be user-controlled templates that can actually be invoked directly through things like UI elements or slash commands. And then resources are also going to be application-controlled data sources that may be presented to the user for selection before being included in any sort of LLM context. Of course, the handling of this in whatever client you're using is going to be up to the client developer, but they're not necessarily going to be strictly for the language model as something like tools are. This is a bit more of a complicated way of saying that tools and prompts are going to be something that's not necessarily controlled by an LLM. Whatever client you're using may choose to handle, or you can develop the functionality to handle resources and prompts a little bit differently and not necessarily even include a model interaction within them anyway. But once again, with a little bit of this stuff being theoretical, it's a little easier to show you what I mean rather than talk about it. So let's talk about the different methods for resources. In my applications functionality, essentially what I want to have is a list of available other resources that are not embedded into my document that the user can either read over or add to as context for the language model. And my simple example here is going to be in my testing folder here. I have the BERT paper, the original BERT paper from Google, here in PDF format. With that, very similarly to how we had the listing and calling of prompts, we'll have the listing of resources as well as the reading of resources. So for the actual listing functionality, this isn't actually going to open up or provide the resource to the user in some way yet. All it's going to do is provide the path or the URI to that resource within the server. So what our handle list resources function here is going to do is look in our testing folder here with our 2 PDFs, check for all of the PDFs, and append to our resources a resource object with our URI, which is going to say document PDF, and then the name, a little bit more metadata as well as the type, and return that back to our client. Our client then is going to have a command. So it is going to be a /command for /resources. And what this will do is call the list resources function here from the server and print out all of the URIs into our command line, which we'll demonstrate here at the end. But along with the resources command, we'll also have the resource command, which is going to call our read resource function from the server. And so this is going to be the server-side handling of actually passing back and loading this specific resource and sending it over to the client. So my handle read resource is just going to take in the URI, reconstruct the path to find it on the back here, and then it's going to use PyPDF loader to just load that as text, combine it all into full text, and pass it back to the client. For some extra functionality, when our client actually calls the read resource, it's going to add all of that to our message history so that the language model, as we're conversating with it, will know that this resource has been loaded and see it. But it's ever so slightly different than what we do with our tools, which is, of course, letting the language model know every single time what tools it has and the functionality to actually invoke those tools without necessarily our own specific intent. This is a little bit decoupled as a command, but still interacts with these static content on our server here. But with a little bit of that out of the way, I'm going to take a small break before we cover prompts and actually show the example so that you can see the tools in action as well as the resources in action. So let's go ahead and start up the client along with the server. And what we'll see here is that it's going to start up the server and all, and here we go. So printing out some of the functionality, we can see that we're connected to our document search MCP server over here. And what I can do is just query it. And as mentioned, this is just going to be a simple language model chatbot in the command line here. So we can see that the language model, which is GPT-4o, actually responded as such. But what I can do is actually say, what do we know about AWS? And so let's go through there. And we can see that we actually made a request to our MCP server. And if we give this just a minute here, we see a nice lengthy response. But we also see that the query document tool was called with the query AWS. And then, of course, our language model's response. So through connecting to the MCP server and handling the connection within our code here in this standardized way, our language model knew what tools were available to it. And when it called a tool that was executed on the server, the context was passed back. This was all given back to the language model, and we get our lovely response here. Similarly, we can try out our resources command. And within that, we see we have the 2 resources, which over here is the BERT and the fine-tune guide PDF. And then we can use the resource command to actually pass in the path to Bert. And so what this will do is, as we saw here, call the server again to load the document. So the document's been loaded, and I have it give a little preview here. Similarly, we could see when we called resources that the server was processing the request of list resources request. Now what I can do is I know that within my client, I've added in the functionality for actually passing in all of this text within context, so I can ask the language model about it. Like, who were the authors of the BERT paper? And then we can see that it should come back, understanding. There you go. All of the authors from the context that we provided to it through the resource here. So that should have hopefully cleared up a little bit of how the client and the server works with both tools and also with resources. And then a little bit of the functionality that I introduced in my own application here for actually handling those and the different interactions with the language model. The last bit here then are of course going to be the prompts. So very similarly to our resources and very similarly to our tools, we'll have a list prompts function here as well as a get prompts function. As has become the theme, the list prompts function is just going to return back a list of prompts. These are of course going to be prompt objects with a few of the standardized schema for the prompt, including of course our names of deep analysis and extract key information, as well as prompt arguments and a description for them. To do a little show and tell, if we type in the prompts command here, which in our client is going to be very similar to what we did with resources, just going to call list prompts from the server and then print them out, we shall see that we have a couple available prompts after quickly talking to the server. And then this is where a little bit of the difference between prompts and tools are actually going to come into play. We're going to handle the execution of the prompt on the client side. So when we use the command prompt along with whatever arguments it is, it's going to format that. It's first going to get the prompt from the server and then format it and send it over to our OpenAI client. But the actual getting of the prompt is still going to be handled through our server here with the get prompt function. This allows us to format when it's called our prompts in a few different ways. So we can use the get prompt result object here to pass in a list of messages. And this is going to be something like an assistant message and a user message. So our prompt is going to be, I am a document analysis expert specializing in identifying key themes and arguments. And then my user message here is going to be a lot more in depth, where I'm informing it to do a deep analysis of the provided document, which is going to be our resource, focusing on whatever the argument passed in was, as well as some things to include in our analysis. This is also going to be the same thing that our extract key information prompt is going to be in the format of, with a quick assistant message to change the conversation and set the tone, as well as some text of how to actually extract that information. And then all we're doing on our side here is taking in these assistant and user messages and formatting them slightly, adding them to our messages, and then processing it with GPT-4o. So if we bring back up our example here and we load the same BERT resource here, we can list the prompts and then say we want to prompt extract key information and say mentions of pre-training. And what it'll do is it will get the prompt and do everything that we just went over. And here in a few seconds, as I fill some dead space while the language model is generating, we should get our response back any minute. Perfect, right here. And we can see that that specific prompt was ran through, and we can see a much more specific response that follows all of the actual instructions that we outlined on our server. But with that, the rest of the code is really just running the MCP server with a standard input-output stream, and the rest of the client is also just handling a lot more of the just formatting for pasting it nicely into the command line, as well as the connection to the server when it's running. If you're interested in the details of how the server clients actually talk to each other and the different transports between them, of course, I recommend looking at the official documentation, which goes into all of these specific details a little bit more than I did. But I hope what I was able to provide to you today is a bit more of an understanding of how these language model applications or clients actually talk to a MCP server, a little bit of what the model context protocol is actually good for, and the different various integrations and ways that you can start thinking of using MCP servers to more standardly attach functionality from maybe your favorite service or local documents to whatever language model based application you prefer using. I'll leave all of the code and examples that I had in the description below, along with some further resources to check out. I definitely recommend checking out some of the cool servers and the lists to both get an idea of what's useful as well as look at some examples if you're actually trying to build your own. There's a lot more advanced functionality and different capabilities of MCP servers as well as you dive into actually building your own. So I only went over a lot of the basics to help people get a better understanding of what they're useful for and how the different client and server side operations interact. So do check out all of these resources. But with that being said, I hope you found a little bit of use or learned something interesting today. If you liked the video, like the video. If you want to see more like this, consider subscribing. If you have any questions, leave them in the comments below. And if you want to support the channel even more, consider dropping a super thanks or joining a channel membership. Thank you and have a great day.